Hello everyone, welcome to a brand new video at Beyond the Cloud. Today, we are going to talk about AWS SAM, the Serverless Application Model, which is an open source framework for building serverless applications on AWS. It provides a simplified way to provision AWS resources needed by your application as a CloudFormation template. SAM integrates with many popular development tools such as AWS CodePipeline, AWS Code Build, AWS CodeDeploy to automate the deployment of your serverless applications. It supports multiple deployment strategies such as Canary, the blue-green deployments to help you safely roll out the changes on your applications. In my previous video, I have talked about AWS CDK, which is another framework for infrastructure as a code. But in CDK, we cannot test our application locally. This is where SAM comes into picture. It is very handy. We can do local app testing with SAM just like it is running in the cloud. This is a major difference between SAM and CDK. We will mainly use Java in this video, but you can use any language, any programming language as you want. If you are new to this channel, kindly subscribe and comment your thoughts. Please share this video as well. If you subscribe, you will be getting notified whenever there is a new video in this channel. So we can go now and check out the tutorial.
Welcome to the theory part of AWS SAM. I have made it very short introduction. AWS SAM or Serverless Application Model is an open source framework for building and deploying serverless applications on AWS. It provides a simplified way of defining the Amazon API gateways, AWS Lambda, Amazon DynamoDB tables needed to build for serverless applications. SAM also includes a local development environment called SAM Local, which allows developers to build, test, and debug their serverless applications locally before deploying them to the cloud. SAM Local supports debugging with popular IDEs as well as integration with local Docker containers. So you can simulate the AWS Lambda environment on your local machine. With SAM, you can define serverless application in YAML or JSON template, which can then be used to package and deploy the application using CloudFormation. So how do SAM works? So on one hand, we have our serverless app developer who wants to develop serverless application, and before deploying, he wants to test. Otherwise, the production will go down for no reason if anything happens. Of course, we can define unit tests, but for real-life Lambda or API gateway testing, we would really need something to test from our local directly. For working with SAM, there are a couple of steps. SAM init. This is the first step when you initialize a SAM project. So SAM init initializes to create a new application with predefined templates. When we run SAM init, the CLI will prompt us to choose between several predefined pre-built templates for the application structure. These templates include AWS Lambda functions, API gateway, DynamoDB, and many more, and can serve as a starting point for building a serverless application. Then comes the SAM build. So the SAM build command is a part of serverless application model, which is tool used for building, testing, and deploying a serverless application on AWS platform. The purpose of SAM build command is to compile the source code of serverless application and package it into an artifact that can be deployed into AWS. When we run SAM build, the SAM CLI will compile the source code in our application, including the Lambda function, package it into a deployment artifact such as zip file. The artifact contains everything needed to deploy the application on AWS, including the code, libraries, and other dependencies. Then comes the most interesting part, the SAM local. SAM local SAM local command is to allow developers to test their serverless application locally before deploying them to AWS cloud. There are several subcommands of SAM local that are part of SAM local, including start API, start Lambda, invoke. The start API command actually starts a local instance of API gateway and allowing us to take the REST API of our serverless application. The start lambda commands starts a local instance of AWS Lambda, allowing us to test the lambda function. The invoke commands allow us to run a specific lambda function and see the results, including the output and any logs generated. The SAM local commands in the serverless application model uses Docker to run serverless applications locally. When we run SAM local, the SAM CLI will create a Docker container that mimics the environment in which the serverless application will run in the cloud. In particular, the SAM local command uses the Docker container to run instances of AWS service such as API Gateway Lambda. This allows us to test our serverless application locally, just as if we were running it in a AWS cloud, to see the result for us in the real time. One key advantage of using the Docker in SAM local is that it provides consistent environment for testing regardless of the operating system or the hardware we are using. The Docker container ensures that our serverless application will run in the same environment regardless of whether we are using a Windows or Mac or Linux machine. Another advantage is that Docker provides an isolated environment in our serverless application. So we can test it without affecting other application or processes running on our local machine. This makes it easier to run multiple instances of serverless applications simultaneously, allowing us to test different scenarios and configuration. So very nice. Our local testing is done. Now everything is successful. Now the main part is coming. So if we remember, in SAM build process, we have created our artifact. So once the artifact is created, the deployment comes into picture. The SAM deploy commands takes care of that. The SAM deploy commands creates and configures the necessary AWS resources for our serverless applications such as AWS Lambda function, API gateway, and many more, and sets up the infrastructure required for our application to run. We can provide the S3 bucket name where the artifacts will be stored, the stack name for the specific deployment, and it will deploy all the resources automatically. We can also specify if we want a guided deployment or not. For IAM policy or role deployment, we have to give consent for capabilities IAM. So one of the key benefits of SAM is that it reduces the amount of boilerplate code needed to define the serverless application on AWS. SAM templates are concise and easy to read, which saves time and effort when building the maintaining serverless applications. Additionally, SAM integrates with popular AWS services like S3, SQS, Kinesis, and make it very easy for build serverless applications that can leverage these services. Okay, now let's move on to the practical and see everything happening in real time. Welcome to the practical of AWS SAM. So first, I will define the requirements to follow through this practical. So SAM will not work properly if these dependencies are not installed. So first of all, we need one AWS account. Free account is also fine, where we will be deploying our AWS resources. We need to have AWS CLI installed in our machine. So this is very simple to install AWS CLI. Also, after installing the AWS CLI, we need to have SAM CLI installed also in our local machine. This is also very much important to give the SAM commands and it will run properly. Then most important part is the Docker installed. So the Docker will create a virtual environment within our machine to test or run the application properly. So Docker is also very much important for SAM to run properly. The fifth one is the JDK, Java Development Kit. So as we will be doing this practically in Java, we need to have JDK 8 or higher installed in our machine. So JDK is not mandatory one. So if you go through with Python, you need to have Python installed in your machine. Currently Python SAM support, I guess, Python 3.9. So you need to have either Python 3.8 or 3.9 installed in your machine. As we are using Java, to build Java application, I have used Maven, and we need to have Maven also installed in our machine. If anyone thinks that we need to have, instead of Maven, we will use Gradle, that will also work. So instead of Maven, we can also build our Java application with Gradle, and that will also work. The seventh important part is we need to configure our AWS access key and secret key in our AWS environment. So this is also very much important. So don't be scared about the dependency. So I will give a link to install each and every dependencies in the description box. Please follow through it. This is very much simple to install, and we will be done with the installation in a couple of minutes. So as I have already installed all the dependencies in my machine, we will directly go through the terminal and run through the SAM commands. So right now we are inside the terminal, and also we are inside the folder where we will run our SAM command. So let's go to our Slido first. So right now the developer wants to build a SAM application and also wants to locally test it. So to make it very simple, we will use a template that is provided by AWS already to initialize the serverless application. So the command for this we already know, it's called SAM init. So SAM init will initialize a project or serverless application with default configuration that AWS provides, or default templates that AWS provides. So after giving SAM init, we press enter, and its SAM init works in an interactive mode. Like it will ask me for option, and after I give the option, it will again proceed to the next step. So to make it very simple, I will choose option 1, that is quick start template. So AWS, as I already said, AWS provides some kind of quick templates to go through or to prepare ourselves for the first SAM build application. So we will hit enter, and then it will also show us that, okay, for quick start template, we have this much template available, and which one do you want to pick? So I will pick up the simple one, the first one, where it will create a Lambda function which will just print out the hello world. And it is asking me that the most popular runtime is Python and zip. Do you want to do that? So as I said, I will be using Java. So if you use Python, you just press Y here. If you are using Java, or if you want to follow any other programming language, just type in N here. So Python is also very nice, but you need to have Python installed in your machine. So I will put it here as N, as I want to do it with Java. So I will go ahead and choose option 7, that Java 8, or we can choose 6 as well, which will create a virtual environment for running our Lambda with Amazon Linux 2. If we click Java 7, if we give Java 7, option 7, it will create a virtual environment of Amazon Linux instead. So we can give either 7 or 6. So let's go ahead and give 6, so that it will create a Amazon Linux 2 machine environment for our Lambda to run. And so this is the one where the package type you will use. I will use the zip one. So I will choose 1 and press enter. Now it will ask me that what kind of dependency manager do you want to use. So as I said, it has 2 dependency manager. One is Gradle, one is Maven. So in my tutorial, I will use Maven. So I will choose option 2, and it will show me the project name, that will be the project name, and it will clone all the code from the repository of a sample template. So right now it is done. All we can go ahead and see that in our IntelliJ IDEA. So right now, this is the one that has been downloaded, and it is already saying me that IntelliJ IDEA is intelligent to show me that it has a Maven build script. So do you want to load it? I will choose load, and then it will show me the project. So this is a SAM app. This is the README file. You see it is already showing me how to build this program, how to deploy this program. So this is very much easy. Now I close this README file, and let's go one by one, and which is the important one in this project. So first of all, the template file. This is very much important. So what this template file is, it is the template file which will be used to create our packaging or to deploy our project itself. So this is the template format version. This is the general format version of AWS, and this is the default one, and the description we can give. So this is a AWS SAM template. We can define the timeout for global function here. This is the function that we will be creating. And the most important part is the resources, where the function name is defined like the hello world function. And the type of this resources is AWS serverless function, that is a Lambda function. And the most important part is the properties. The code URI defines from where the Lambda function code resides. So it is in the hello world function, which is this one, this folder. And what is the handler of it? So in Java, we need to provide the handler like this: hello world, then app, this is the class name, and this is the method name. So if we open this up, we have source, main, and then Java. Inside Java, we have this hello world like this one, and then we have app, this is the class. And inside the class, we have this method called handle request. So if we again see the template, this is the handle request. So this particular property tells that go into this folder and pick up this method from this class. So this is what it tells. And the runtime will be Java 8 with Amazon Linux 2. That's what we have chosen. And the architecture will be x86-64. The memory size is 512, which is fine. There are a couple of environment variables options, so this is not important right now in our tutorial. And also we have a event API event which we can delete because we will not use it. So let's delete these events. This is for invoking. And for outputs, we have couple of outputs, like if it is creating an API gateway, then it will create the output like this. And so for CloudFormation template, as we know that SAM will create a CloudFormation template and deploy the stack into our account. So this is the outputs where we can see the output of the hello world function, like its ARN where it is created, and the IAM role, the role it is created for the function execution role. This we can see, but right now we don't need that. So we can also delete the output here, output section, to make it very simple. So in this template, we currently only have a Lambda function, which runtime is Java 8 with Amazon Linux 2, and it is taking this handle request of this app class. Now in the handle request method, we are setting the content type as JSON and application type, and the custom header is also application JSON, and it is only printing this hello world, nothing else, and returning a 200 the 200 code if the call is successful. That's all. So this is very simple, and we have inside our hello world function, we have pom.xml. So if you are familiar with Java, this is the one which is required, the Maven, for building our Java code. So when the SAM build will be called, it will ask this pom.xml, hey pom.xml, which compiler you want to use for Java, and Maven tells that I want to use Java 1.8. So the Maven will run the Java 1.8 compiler, and it will compile our code, and it will create the build version of our code. So this is the main part, and nothing is important here. And also event, this is important if we want to invoke our Lambda with event. We can give one event format here, but right now we will be not invoking our Lambda with events, so this is not important. So to make it very simple, we will go back to our terminal now. And right now we are in the SAM folder, so we have to go one step inside, which is SAM app. So right now I am inside this SAM app like this, and here it will find the template.yaml. So if we go back to our slide, we see that we have initialized a project, and it has created one predefined template. We are not changing anything at all in the template. We just want to run the Lambda in our local. So to run the Lambda, before running the Lambda, we have to build the project. So we will use Maven. I will first clear the screen, and then I will run SAM build. So while I will run SAM build, please look into this structure again. Right now, I don't have any build folder at all in this one. So as soon as we run the SAM build, it will build all the dependency. It will copy all the dependencies from Maven artifacts, and it will show me that build is successful for Java, and it has builded with Java 8 compiler. Now, if we go back to our folder structure, we see that one AWS SAM project has been created, and this is the build file. We have our hello world function, our template file, our library, dependent library of this hello world function, and the function itself. This is the class file. So we are all good. Now, if our build is complete. Now, if we go back to our slide, what we can see is we have to test our application locally, that if the function if the AWS Lambda function is working properly or not. So to do that, we need two things. We need to have installed Docker in our machine, because Docker will create a virtual environment where the Lambda will run, and we need to configure AWS account in our local. That means this is where our access key and secret key will come into picture. So I will copy the access key and go to the terminal first, and I will run AWS configure, and this will ask me my access key. I will give my access key. Then it will ask me for my secret key. So I will give the secret key, and that's it. I want to run this Lambda function in this region and default output format. That's it. So I have configured, I have bootstrapped my AWS account into my local environment. So right now AWS CLI, if I run anything with AWS CLI, it will refer to that particular account. Now, if we go back to our account, we see this is my account where I have bootstrapped, and let's go to Lambda. Only one function, but this is the account initialization function, so there is no function at all. Now let's go back to the terminal again, and we have already defined AWS configure, and we have done that. Now the most important part is the Docker. So we have to install Docker, and Docker needs to run in our local machine for SAM, for local invoking. So right now, if you see, I have 4 images. None of them are Java. These are from Python images, and there is no images currently running. What we will do, we will go back to terminal. Before that, we will go back to our keynote, and we say that whenever we will give the SAM local command, it will invoke the Docker, and it will create the image, and it will run our Lambda function as a Dockerized container. Let's see that. To run this AWS function in Docker repository, we have this command that we have to give. This is very simple. So first of all, SAM local, then invoke, and then we have to give the function name. The function name we can get from our code. This function name we want to invoke. We will go back here, and we will give the function, and we have to select that we will give no event. So this function will have no event, and it will be invoked as it is. So when we invoke this command, you see we are getting one output called building image. Now very interesting to see, if we go back to Docker and if we refresh it, we see that one of the image has been created. That is this one. This is the one, public ECR emulation Java 8 Amazon Linux 2. This is currently created, and the package is done and everything. So this image they have built up, and it has build up the image from the AWS CLI emulation image. So it is a public repository image, and it grabbed the image, and it ran in my local. So if we go back to our keynote, if we go back to our terminal, we see that our AWS Lambda function has been ran already, and we see that the Lambda output is this one, hello world, and the header is like this, and the status code is 200. That means our Lambda ran, and our Lambda ran inside this Docker container. So if we go back to our keynote, that whenever we invoked our SAM local, it created one, it grabbed the image from the public repository, it ran the Lambda function in Docker, and it created the output in our terminal like hello world location. So this is very interesting. So if we have a Lambda function which we want to test from local before deploying into production, this is very convenient way of testing a Lambda. So the secret key and access key have the IAM role to invoke the Lambda, so we don't have to bother about it. But if the secret key and access key that we are giving here does not have the Lambda invoke permission, it will not work. So it's good to have the permission assigned to the user that we will be using here for configuration to invoke the Lambda function. So this is easy. Now the important part is the deployment. So when we see the Slido here, we see that SAM deploy, when we will be calling the SAM deploy, it will create an S3 bucket. We need one S3 bucket where our dependency and where our artifact will reside, and from that it will create one CloudFormation template, and from that CloudFormation template the stacks will be deployed, whether it is a Lambda function, whether it is a API gateway, DynamoDB, and many more serverless functions. So let's see that in action. So to deploy this, we need to give this command SAM deploy with couple of options. So we can give SAM deploy with the S3 bucket that we want to post the artifact. So the S3 bucket name we will give like maybe anything, SAM bucket demo, then a constant number, maybe random number, sorry. And then we have to provide a stack name. So this is the stack will be created in CloudFormation, and the CloudFormation will deploy the resources with this stack. So we can give as my stack, and then we have to give a permission for this as it will create. Why do we need it? Because it will create a so let me write it first. Okay, why does it need it? Because if any IAM permission or role it needs to create, it will create it automatically if we give the capability of IAM, because IAM is a global service and it is a security related issue. So it is always it will always fail if we don't give the capability IAM here. So right now the deploy command is complete. So SAM will deploy the S3 bucket. So let me just do it a bit bigger here for better understanding. Okay, so SAM deploy will deploy the artifact into S3 bucket named this, and from that it will create a stack called my stack, and we have given the capabilities I am already, and let's give enter. Oh, okay. So sorry, now I think I have to create the bucket first. So let's go back to our console and sorry. So this bucket right now exists. Now we will go ahead and deploy the artifacts there. So we see here the stack name is my stack and the region name is this one, and the deployment bucket is this one, the one that we have created, and it is waiting. So let's go and check the resources there. Also, one thing here is that CloudFormation stack sheet has been generated, and it is creating one function role, execution role here, and the Lambda function itself. So we go back to our console here and we refresh this, and then we inside the bucket we see the artifact and the template file here. And if we go to CloudFormation, it is showing that one stack is in progress. So if we open the stack, it is showing creation in progress. If we go to resource, we see one Lambda function it will create and one IAM role it will create. Great. So that's all. The stack is completed now. Now, if we go back to terminal, it is also showing that we successfully created the stack in US East 1. And let's go back to Lambda. And this is the one where it is showing my stack hello world function. And this is the one where it shows that Java 8. So the code is uploaded, but right now it is not able to editor because so it is not our issue. It is AWS issue anyway. So we can test the function. So we will create a test event and we will do the testing. So in the backend, it invoked the Lambda function and it is showing the same result that we have seen in our terminal. So we have seen that our terminal like this. This is the one where we have seen the hello world location, and this is my IP address from where it is invoked, and this is in the Amazon AWS IP address from where it is invoked. So this is how SAM is invoked. And if I go back to our keynote now, so we have initialized a SAM project, we have built the SAM project, we have locally deployed the SAM project, and we have tested it using a local Docker container, and we have deployed the SAM using an S3 artifact and a CloudFormation template which deployed the Lambda function in our account. Okay, so now as our deployment is completed and our testing is completed, now we want to destroy the resources that SAM has created. So to destroy the resources that SAM has created, there is no destroy command in a newer format. So they have changed the destroy command to delete. So all we have to give is SAM delete, and then we have to provide the stack name that we have given. So the stack name is like this, and I will go to my console and I will take the stack name, my stack, and I will paste it. So this is what the command is. So SAM delete, and then the stack name is the stack name where we have created. Now press enter. If we hit enter, it will ask me if we really want to delete the stack that is created in this region, and I will press yes. And also it is showing that we have in S3 bucket, we have our template file. So do you also want to delete that? I will also press yes. So it will delete. So the S3 object key is deleted, the template file is deleted. Now the CloudFormation stack is going to be deleted. So if you see here, it is showing deletion is in progress. And if we go to resources and refresh, we see that delete is completed. Both the IAM role and the Lambda function is deleted. And also if we just again refresh, I hope the stack is gone now. So the stack is gone. And it will take some time to grab the response from the AWS account to this terminal. Now it is already got the response, and it is showing me that it is deleted successfully. So this is how you delete a stack that is created by SAM. So this is it with the tutorial. This is a very short tutorial about AWS SAM. I will give the description of the dependency, how to install that in the description box, and also I will give the code base of this one in the GitHub repository where I have uploaded the code in the description box as well. So in my previous video, I have discussed about AWS CDK, and in this video I have discussed now with AWS SAM. In the next upcoming video, I will be discussing with AWS SAM and CDK together. So because together this SAM and CDK works together very nicely. I am also excited about that video. I hope you are too. So that's all. In the end, I hope this video was informative for you and you liked the content. I will make more such video in near future. If you like this video, please like, share and subscribe to this channel. As my channel is very new, kindly support me by subscribing. Please also give your valuable comment in the comment section. Please check the description box for the code. I will be back with another exciting video, like I said, with SAM and CDK together. So till then, bye bye and take care.